In this lesson, we will go over logical operators. In previous videos, I talked about if statements and how to evaluate conditions. For instance, if we had a variable, my integer, we could evaluate if my integer is less than 10 and perform an action if that is true, and if that is false, perform a different action. If we were to write that in code, we would define an integer. We'll say my integer is equal to 4 initially, and we could write an if statement. If my integer is less than 5, do something. In this case, the condition would be true and the contents of the if block would execute. Sometimes you may want to evaluate variables in more than one expression. An expression is a single condition you may evaluate. So for instance, my int is less than 5 would be considered an expression. But what if you wanted to evaluate two things together? Maybe you only want to do something if my int is less than 5 and the day of the week is Tuesday. Otherwise, do something else. You can tie expressions together using what are called logical operators. In my prior example, I said I want to evaluate that my integer is not only less than 5, but also that today is Tuesday. This would be what is called a conditional AND operator. You want to make sure that condition or expression 1 is true and expression 2 is true. If both of them are true, then you will evaluate the contents of the if block. To see this in code, I'll write a string day of week equals Tuesday. In code, I can look at my if statement. The first expression is already there. My int is less than 5. I can use the logical operator, the conditional AND, using two ampersands, and then check to see if the day of the week is actually equal to Tuesday. If and only if these two expressions evaluate to true, will I execute the contents of the if block. Maybe we only need one condition to be true. In English, we would express this as either or. Either my integer or my int is less than 5, or the day of the week is Tuesday. If it's Tuesday, we don't care what the integer is. You would express this using the conditional OR operator. The conditional OR operator is written as two pipes. If you're wondering what a pipe is, hold down Shift on your keyboard and hit the / key on a traditional US keyboard layout. So again, in this case, either my int is less than 5 or it's Tuesday. Either of these could evaluate to true. Both of these could evaluate to true. And in both cases, I would execute the contents of the if block. The only case where I would not is if both evaluate to false. Before we go any further, these can be expressed using a tool called a truth table. You may have built truth tables in some of your prior math courses. A truth table is used to determine how expressions behave when combined together using conditional operators or Boolean logic. Truth tables are exactly that, a table. In this case, we will look at the conditional AND operator. Two ampersands together. You bind two expressions together using two ampersands. When looking at this truth table, let's take expression 1. If expression 1 evaluates to true, and expression 2 evaluates to true, the complete expression of expression 1 and expression 2 would evaluate to true. If expression 1 is true and expression 2 is false, the expression 1 and expression 2 would evaluate to false. If expression 1 is false and expression 2 is true, if you AND these together, which is another way you may hear this or see this phrased, the overall condition or expression will evaluate to false. If expression 1 is false and expression 2 is false, expression 1 and expression 2 would yield false. This is the truth table for a conditional AND operator. You have two expressions grouped together with two ampersands, or the AND statement. If expression 1 and 2 are true, this is the only time the overall condition would be met, as both of these together would yield true. We can use this same table to evaluate the OR operator. I had previously stated this can be expressed in spoken or written word as either this or that. If either is true, then the condition is met and the overall expression is true. Let's start again. In the case of OR, the truth table would be evaluated as this. If expression 1 is true and expression 2 is true, expression 1 or expression 2 would be true. If expression 1 is true and expression 2 is false, expression 1 or expression 2 would yield true. If expression 1 is false and expression 2 is true, expression 1 or expression 2 would yield true. If expression 1 is false and expression 2 is false, expression 1 or expression 2 would be false. These are the truth tables for how and OR are evaluated. There are other types of operators that can be used in certain cases. Sometimes you want the inverse value in an expression. Let's look at our code and let's see we have a Boolean myBool, and let's set it to false. Normally, we could write a statement such as if myBool is false, do something. This could also be written as if my bool is not equal to true. Notice we used an exclamation point or bang mark and an equal sign for not equals. The Boolean not operator could also be used. If we wanted to evaluate if my bool was true, we could simply write my bool. In this case, we would never do anything because my bool is false. However, using the Boolean logical not operator, if not my bool, which is, in essence, if my bool equals false, do something. In this case, we would hit this block. The not operator is used here in order to flip the bit, or to look at the inverse of the truth within this condition. If we were to convey this in a truth table, it would be written a bit differently. In this case, there is only one expression. Expression 1. If expression 1 is true, then not expression 1 is false. If expression 1 is false, then not expression 1 is true. The Boolean not operator flips the value of the expression's condition. This is also called the logical negation operator. Let's look at how we can use this to essentially flip the values of our expressions. Let's say we had an integer, my int equals 5. And let's say we had a condition, if my int is less than 4. In this case, we would do something, because we have this if block. Now, in the case of my int equals 5, we would never encounter the contents of the if block because my int, which is 5, is not less than 4. However, the logical negation operator could be used here to flip the statement. Here, 5 is less than 4 evaluates to false. However, using the logical negation operator, not, while my int, or 5 is less than 4, evaluates to false, we then flip that value to true, using the not or logical negation operator. In this case, we would then hit the block of code within the if statement because the overall expression here evaluates to true. There are other Boolean logical operators which you may encounter. You notice that we typed in 2 ampersands as a way to evaluate an expression. The ampersand, or the pipe for or, can also be used in statements. So we built out a truth table to talk about and or. Those had 2 ampersands for and 2 pipes for or. The Boolean logical and or can also be used to combine values to complete a statement. So let's say we had bool my bool equals true. And bool, your bool, equals true as well. We could then create another variable, bool, our bool, equals my bool and your bool. This would yield true, because what we are saying here is my bool and your bool both being true ANDed together would yield true. How do we know that? If we look back at our truth table and rewrite it for AND, we see for the logical operator AND that true and true yields true. This is the same for the Boolean AND. Evaluating an expression that is true and combining it with another expression that is true will yield a value that is true. If your bool was false, our bool would be false. If these values switched and my value was false and your value was true, our bool would be false. The same would happen if your bool and my bool were both false. Let's instead use the Boolean logical OR. My bool or your bool, when both are true, yields true. When your bool is false and my bool is true, our bool would yield true. If these were flipped, our bool would also yield true. And if both were false, our bool would be false. There is one more operator which you may encounter, and that is the Boolean logical exclusive OR. You will see it written as XOR. Logically, this could be explained as if you had two values, the logical combination of those values would only equal true if each of those values had a different value themselves. So if one operand or value is true and the other is false, if both are true and both are false, the statement would be false. If one is true and one is false, and either one could be true or false, then that would yield true. So if we write the truth table for a bitwise exclusive Boolean OR, true and true would equal false. True and false would equal true. False and true together in a bitwise exclusive OR would equal true. You could also say this as false bitwise exclusive OR false would equal false. This may seem strange now, but bitwise exclusive OR is used many times for mathematical evaluations that you may encounter in larger scale applications. This may seem complicated at first, but building out Boolean and logical expressions will be quite important as you do make decisions in your application And as you evaluate user input,